So this video is a review of Polaris, the North Star, which is an incredibly important star for many reasons. So we'll outline those in this review video. Feel free to pause it at any point, rewind, listen to any of the pieces again, and then come find me if you have any questions. So this picture shows our galaxy, the Milky Way galaxy. They say it looks like milk was spilled across the sky. That's why it's called the Milky Way. There's a band where there's simply more stars, and so those stars look a little bit brighter. So that's why they call it the Milky Way. The Milky Way is one galaxy. It contains billions of stars, between 100 and 400 billion stars. They can only estimate because you can't count that high. And the universe contains billions of galaxies. This is a picture of galaxies outside of our own, each galaxy containing millions or billions of its own stars. So bringing it back to Earth, though, all the stars we see from Earth are in our galaxy. We can only see a fraction of those with our eyes. This is a picture that shows Andromeda, our closest neighboring galaxy. Throughout history, different civilizations have used the stars for lots of reasons, to find their way, to tell stories, to explain things. Different cultures have looked at the stars and made shapes with them. This is the constellation Orion. This is the constellation the Big Dipper. So the Big Dipper is, keep it in mind, we're going to come back to it later, but the Big Dipper is one of the brightest and easiest to see all year long. And in the fall and winter, Orion is one of the brightest and easiest to see. So those are some nice constellations to start looking for. You can see both of these things from New York City. So bringing it back to Earth, Earth's axis, which we know is tilted, is pointed towards Polaris at every point during the year. So our axis happens to line up with a pretty bright star called Polaris. Polaris is the North Star because it lines up with the axis. What that means is that throughout the day and throughout the night, stars appear to make one complete circle around Polaris, the North Star. Now we know that the stars aren't actually moving. In fact, Earth is moving. Earth spins. So in that 24-hour time period, Earth rotates and it makes it look like everything else is moving. We are moving, not the stars. So, sorry about that. So Polaris is a really useful star. Because the North Pole lines up with Polaris, that means Polaris always points north. So if you can find Polaris, you can always find north, which means you can always find south, east, and west, and it makes it a lot easier for you to find your way. So how do you find Polaris? So back to the Big Dipper. So if you can find the Big Dipper, again, one of the brightest constellations in the sky, has 7 super bright stars. It makes this soup ladle shape, like a big spoon. So they call it the Big Dipper. And you take the last 2 stars at the bottom, right here and right here, and you line them up. You take this distance and you take 5 times that distance. It'll point to the North Star. The North Star happens to be at the end of the Little Dipper, which is a different constellation, but the Little Dipper is much fainter and much harder to see. So you can always find the Big Dipper, which means you can always find Polaris. Little Dipper is a little harder to see. That's true even as the stars appear to make an orbit around Polaris. Polaris will stay in the same location. The Big Dipper may look like it's in a different location, but the last 2 stars will still point towards Polaris. So you can always find north if you can find the Big Dipper. So what does this mean? Well, depending on where you are on Earth, Polaris is in a different location. So if you look at this little guy on the left, he is standing on the North Pole. If he's standing on the North Pole, that means Polaris is directly above him. So Polaris makes a 90-degree angle with the horizon. Now, the closer to the equator he gets, the lower Polaris gets in the sky, and the angle that it makes is lower. So Polaris not only points north, but it also tells you your latitude. So the altitude of Polaris, its height in the sky, is equal to your latitude. At the North Pole, Polaris is 90 degrees directly above you, and you are at the North Pole, so you are also at 90 degrees north latitude. If you're standing in New Orleans, Polaris would be 30 degrees in the sky, and you would be 30 degrees north latitude. If you are standing at the equator, Polaris would be at the horizon, or 0 degrees, and you are at 0 degrees latitude. So to summarize, the North Star, which is called Polaris, is a special star. The height of Polaris in the sky can tell you your latitude on Earth. Because Polaris lines up with the North Pole, its altitude or its height is always the same as the observer's latitude. So for example, the observer in the diagram is at 66.5 degrees north latitude. You can't see Polaris in the southern hemisphere. The Earth would block it. So it's only visible in the north, and it tells you your latitude. So quick question. These scientists are using Polaris to calculate their latitude. I like this picture because it also shows how you find Polaris. It's sort of an old school drawing. So a little harder version of this question that I've seen on Regents in the past actually requires you to use your map of New York State, this one that's on page 3, the Generalized Bedrock Geology map. So the question reads, to an observer in Buffalo, New York, the North Star Polaris is always located above the northern horizon at an altitude of approximately, and then it gives a few options. So for this question, it tells you that you're in Buffalo, and it's asking what the altitude is. So since we know that the altitude and latitude are always the same, if we can find the latitude of Buffalo, New York, we can find the altitude of Polaris. So if you use this map, you can find the latitude lines, or there are no lines, but you can find the latitude numbers on this map. I've highlighted them in pink. This line at the bottom is 41 degrees north. That's the line that runs close to New York City. So in Brooklyn, we're a little bit below 41 degrees north. We have 42, 43, 44, and 45 degrees north. So now all we need to do is find Buffalo and see which line it's closest to. So you may want to get out your reference tables, pause the video, get out your reference tables, and try and find Buffalo. All right. If you were looking at your reference tables, you saw that Buffalo is right over here, which is closest to 43. So of course, our answer is B, 43 degrees. So that's it for Polaris. Come find me if you have any questions.